Now let's take a look at some equivalence between timing adjustment and convexity adjustment. Now for timing adjustment, we have this relationship, this E excitation of VT with numerator asset being the zero coupon bond that matures at T star is equal to this excitation of VT, where the numerator assets a different zero coupon bond that matures at big T rather than T star, and multiplied by this adjustment factor here. Now, in the framework of 5.1, where we looked at a zero coupon bond for a convexity adjustment, we want to show that, in effect, for the consistency, we can say that the R naught that we use there in example 5.1, which is the implied yield from the forward price of the zero coupon bond, is essentially this expectation, where the expectation of the realized yield at T, but with a numerator asset being the zero coupon bond that matures at T star instead of T. So we claim that if this is the case, the two will be consistent. And indeed, you will see that it is the case. So here we're going to show that if we take this R naught as this, and we go through a timing adjustment, we essentially will derive the same expression as the convexity adjustment. So that shows the consistency between the timing adjustment, or the equivalence, I should say, the equivalence between timing adjustment and the convexity adjustment. And that linkage is actually this. So suppose that, let's just take this and see whether we derive the same expression. So if this is the case, that means R naught is equal to this thing, which is equal to this multiplied by this adjustment factor. Although when we do the timing adjustment, we derive this through prices. But we have shown earlier, in earlier lecture, that whether it's a rate or the price, the adjustment on the numerator changes is exactly the same form, okay? So we just take that result and use it here. So R naught is equal to this expectation times the adjustment factor, okay? It's consistent to this. Now, given that's the case, so let's just try to make it consistent with the expression in example 5.1. So we're just gonna take T star minus T as tau here. So rewrite that. We have this expression here will be in this form. So we don't have T star minus T, we don't have a tau. Okay, and M is 1 over tau. So in example 5.1, if we go through that convexity adjustment, we basically derive a form like this for zero coupon bond. Okay. Now here, this expression is basically this, right? So we try to be consistent, which replace this T star minus T. We have this expression, which I rewrote it here. Now, we see that rearrange this, we have this E expectation hour t with t and with the numerator asset of zero coupon bond mature at t is equal to R naught times this thing. So we dropped out the negative side there. And we know e to the power x is, approximately equal to 1 plus x. Okay, so that's a first order approximation. So this thing times that is equal to this thing times 1 plus what's in the bracket. So R times that will get R plus R times the one in the bracket. That's where you see this R square here, R naught square. So then you compare that, you see this thing here is exactly that, which shows that a convexity adjustment here is really the timing adjustment when we have R naught is really equal to this particular expectation. So this is true for the zero coupon bond.